I have developed a prop box of resources to introduce and progress through the topic of geometric and number patterns over stage 2 and 3. There is a range of materials, activities, ideas and relevant information to guide a teacher and their students through different experiences to acquire the knowledge, understandings and skills associated with this specific topic. The first activity uses a stage 2 appropriate book, Leaping Lizards by Stuart Murphy, as an introduction to the topic of geometric and number patterns. This story is about 50 leaping lizards show, but when it starts, the snake director only finds 5 lizards. The lizards start to turn up in groups of 5 and add to the group until they reach 50 and continue the show. As you can see, each page 5 more lizards are added to a chart which shows pictures of the number of lizards along with the corresponding number. This book could be used at the start of Year 3 to stimulate and distinguish students' current understandings of pattern through formative assessment strategies like informal class discussions and demonstration of practice. As a class, you can discuss what a growing pattern is and describe the sequence in the book of counting or adding by 5. In small groups, students can use Lego, joined in lots of 5, to create a pattern using the chart in the book to show how many lizards they have made it to the show. By using the chart as a reference, children can begin to understand how to construct more complex number patterns with concrete materials. You could also ask students to extend the pattern if they are confident and can identify the sequence of adding 5 straight away, as they should be able to as 2, 5 and 10s are taught in stage 1. By undertaking this simple assessment for learning tasks, the teacher can adapt future lessons and see where their students are succeeding or struggling with the topic. The next activity focuses on basic arithmetic sequences using pattern blocks or counters as concrete materials for students to gain a visual understanding of growing number patterns using addition. I don't have any pattern tiles or counters, so I've had to adapt with what I have. I have adjusted an exemplar provided on the education program's work of visual number patterns in an activity which addresses the stage 2 patterns and algebra content for Year 3, which is describe, continue and create number patterns resulting from performing addition. So during this activity, the teacher can use concrete materials, as I'm going to show you, or an online pattern maker tool to complete the first 3 terms of the number pattern for the whole class. So you can start off by 2s, which they should already recognise from stage 1. This is an L sequence, so you can see that they've given you the pattern tiles, and you can just drag them down and give them the first 3 terms of the number sequence, and then you can actually explicitly explain to them and help them to continue the number pattern and describe the strategy behind it. So this is effective when you have a whole class because everyone can see it. You might do it on the interactive whiteboard and also get students to come up and help. So the students can then individually work on their own, and they can actually, if you put patterns up onto the interactive whiteboard, they can have their own sheets of paper and work with the pattern tools or counters, and you will tell them to put the actual number under each of these so they can recognise the sequence. So they'll count each counter. So the first one will be 2. The second one, it is increasing, and that's 4. And then they will recognise that it's actually adding by 2, so the next one would be 6, and they can still count all them. After that, they can also, to move into the more abstract and pictorial side, they can write the number pattern. So it'll be 2, 4, 6, and then they will continue the pattern. So the next row, they would have 8 tiles, and then they would have 10, and they can keep going from there. Another idea is also for groups. So students, once they understand this process, they can take turns in pair to create the first 3 terms of the number sequence, and then the other pair would continue the sequence and then also explain how they got how they continued it using their strategy. So these visual aids can also be used with more advanced processing. So later on down the track in Year 4, 5 and 6, when they begin to do subtraction, multiplication and geometric number patterns, they can do that usually when it involves lower number patterns. So as I've shown here, they can start out by counting with 2 and then they have 2 there, so they're going to double it, and each time they're going to double it they have 4 and then 8, and they can write the sequence as well, and then double that again, and they can double that with the concrete materials. The teacher, while doing these activities, can also ask questions for the students to demonstrate their understanding, such as what will come next in the pattern and how do you know. And it also links to student and pedagogy in the 3 circles, as a teacher can adjust the activity to use with the whole class, a small group work in pairs, individual assessment, or even to provide strategies for students who need assistance. So if students need assistance, they can use these concrete materials when they're faced with the actual number sequences. And students also are given the opportunity to demonstrate their understanding by creating and explaining, which links to the working mathematically strand. And teachers can identify by this if students can actually analyse and describe the growing patterns. And as students are doing this activity, you can start to monitor them, and when they immediately write down the number sentence without actually having to count each counter or tile in the pattern, they are ready to move towards a more abstract representation of patterns. I've also chosen to include number lines, which can be used to introduce and explicitly teach number sequences using subtraction, multiplication, and also those with fractions and decimals via pictorial representations. So vertical or horizontal number lines can assist students by providing visual support for the process of recognising and continuing number patterns from any starting point. So a teacher could do activities which gets students to identify and describe patterns when counting forward and backwards, as explained in the syllabus. So it provides students with if you provide students with a number, so say if you started on 4, you give students a number, you can highlight it, and then you can count on or backwards. So if you plus 4, so you're counting 1, 2, 3, 4, and then you mark the next one. And then you keep counting 1, 2, 3, 4. And you can keep going the whole way through. Another way to do it is you could do a subtraction. So you could start at 60 and say minus 3. So you're going back 3. 1, 2, 3. And then going back 3. 1, 2, 3. So this could form a number pattern. So it's 60, 57, then 54. And the rule is that we're taking away 3 each time. You can also do multiplication. So if you start at 1, and this is geometric patterns, and you times it, say, by 4 each time. So 1 times 4 is 4. 4 times 4 is 16. And then you keep going. So the transfer of understanding from pictorial representations to abstract, as students should begin to automatically get numbers without actually having to count them individually. So they should start to recognise 4, 8, 12 and keep going. So as students explain their strategies, they should also start to and be encouraged to use more formal mathematical terminology rather than just goes up or goes down by. So this is words such as term, so that's each number in the sequence. So this would be the first term, second term, and also same as increases and decreases. As students progress through Year 4, they should also begin to become competent with more complex number sequences, so the subtraction and also the multiplication. And number lines can also be used as an assistance tool when counting up or down for basic written number sequences. So such as 7, 15, 20, 23, which increases by 8. Students may be able to identify that it goes up by 8, but need help to keep counting on. So they're a really good pictorial tool. Hundreds charts can also be effective to use when investigating visual number patterns as outlined in the Stage 2 syllabus. Students can employ and practice their problem-solving skills by identifying and discovering new patterns on the chart. It is considered a pictorial representation with some abstract aspects. This activity can also be done on an interactive whiteboard using an interactive hundreds chart from the ABCR website for the whole class, then individually by using laminated hundreds charts to highlight and reuse. Our teacher can introduce multiplication patterns by exploring multiples of various numbers to create sequences. Teachers should start with simple patterns by highlighting numbers on the hundreds chart, such as 3 and then 6 and then 9 and then 12, which are all multiples of 3. This website can be used if you don't have hundreds charts, and it's also effective when you have a whole group, as they can come up and touch the screen and the teacher can control it. So on the hundreds chart, students can also continue it, so they can go 3, 6, 9, 12, 15, and then you can show the students that they all form a pattern as they're all multiples of 3, and then you can ask students to continue this pattern on their own, so they're going to keep going and start to see the pattern that's forming. You can also have students write one sentence at the bottom explaining how they found the pattern, and also just to discuss their strategy when they found it out. Students can also explain, say in a class situation, what they see and think is happening, and identify the rule for each pattern. So for this rule, you could say that it's going up by 3. So every time it's increasing by 3. Another extension activity which also links to using the hundreds chart is a interactive game, and it links to the process of using the hundreds chart to identify and create patterns. So the activity generates random patterns on a chart which has 60 numbers. So these can be random patterns, and they have the corresponding sequence down the bottom, which could include addition, subtraction, or the multiplication sequence. Then they have to predict the next 3 numbers in the pattern. So this one is going up by 3s as well. So the next one would be 45, then 48, then 51. Then students can check their answer, and it also provides the rule, so it's add 3 to each term. So the use of this ICT can creates very simple and quick problem solving for students, so they can have varying levels of challenge. Matches or paddle pop sticks are useful to use so students can begin to understand the difference between repeating patterns and growing patterns. Using the worksheet from the Maths Plus textbook for Year 5, students can physically create and extend a series of shape patterns using concrete materials. So the first pattern uses triangles. Students can work individually or in small groups, extending the pattern by adding an extra shape and physically counting each paddle pop stick to complete the table of values. So students can work with these materials and continue the pattern. So this next one will have 4 triangles, and they can physically count each triangle along there. So students should begin to recognise the relationship between the number of shapes and the number of sides. So say for this is 3, the third term in it, so it'll have 3 sides in each shape, so it'll actually be 9, so the third term is 9. From this, students can discuss the rule for each geometric number pattern and use it to calculate a larger number. Students are demonstrating how they use generalization when they develop rules for patterns and can apply it to larger numbers. So in addition to this worksheet and activity, students can also go on a website which has an interactive game. When they start to begin abstractly understanding how to calculate the number pattern and rule, this online game can be used to reinforce the process and make it more quicker. The game provides the start of the number sequence, as you can see, so it's 4, 8, 12, and then you have to move the squirrel along for each term and go up the tree till it reaches the next number in the sequence, and then you keep going along until, so you do the 4th and the 5th term until you get to the last tree, and then you have to identify a larger term. So it says you can either identify the 7th term, the 10th term, the 20th term, or the 100th term. So the teacher can choose which term students will calculate to according to the level of challenge they want. This Chinese dragon game is an interactive activity on the computer for number sequencing patterns and multiples. The game can be used across stage 2 and stage 3, as teachers have the option of choosing different levels for each student's mathematical ability and depending on the area they are currently learning. So this includes addition and subtraction sequences from 1 to 5 or 1 to 10, starting from random numbers. So if we go into sequencing, you can see we can do simple sequencing, counting in ones, from even numbers, or counting in twos, and they will form patterns that you have to create. And then you can go counting in multiples. So as we just showed before, we can count in 3s, we can count in 5s, we can count up in multiples up to 9, and then we can also count in different steps. So if we go to counting in multiples up to 9, in this one, they start at random numbers as well, so it's a bit more of a challenge other than just 1, and they can include whole numbers, decimals, and negative numbers as well. So students are provided with the first 2 and the last number of the sequence, and they have a range of numbers to pick from to complete the 5-number sequence. So this one will be 63, 70, so we're adding by 7s, so we can click 77 onto that one, 84, and then 91, and then we can check our answer. So this offers a virtual learning environment, and it offers more opportunities for practice to improve the speed and understanding for students. So the last activity includes some assessment ideas. So as students become more confident with more abstract understandings of geometric and number patterns, teachers can start to use word problems or verbal instructions. Students have to apply their knowledge to new situations to complete increasingly complex geometric and number patterns. For example, a teacher can assess the class by giving a set of instructions where students have to follow and create the sequence, such as, if I start at 9 and increase by 3 each time, can you write the next 4 terms in the number sequence? Word problems can also be written on worksheets to complete, such as, Bonnie swam 5 laps on Sunday, 9 laps on Monday, 13 laps on Tuesday, 17 laps on Wednesday. If this pattern continues, how many laps will Bonnie swim on Friday? Teachers can adapt these problems to suit students in both stage 2 and 3 as they become more